Hello everybody and welcome back to Maths with Miss Buick. This is the first video on De Moivres Theorem. So let's recall, polar form is z is equal to r cos theta plus I sine theta. Well, De Moivres Theorem is very similar to polar form except we've got a power on our z, so the n here represents the power. And we have it's equal to r to the power of n cos n theta plus I sine n theta. So you can see here that there is a power or a number here and here, and you can see that it's not in the polar form. So let's begin by looking at our question. Z is equal to negative root 3 plus I. Use De Moivres theorem to write z to the power 4. So to begin this question, we start off by working out the polar form of this complex number. So let's plot the complex number to see where it is on our quadrant, or which quadrant it is in. So our real and our imaginary. So we can see that negative root 3 is the real part, so we know it's over here. And then we've got positive 1i, so that's up there. So our complex number is in the second quadrant. So let's label this as alpha over here. So we'll begin by finding out what is the value of our r and what is the value of our reference angle alpha. So r is equal to the square root of a squared plus b squared. So I would recommend learning off that formula. So we have minus root 3 to be squared plus 1 to be squared, which is root 4, which is 2. So the value of our r is 2. Now let's look at the value for our alpha. So our alpha is equal to tan inverse of b over a. So we've got tan inverse, our b is 1 and our a is root 3. Now notice again, I'm not putting in the negatives here because tan is opposite over adjacent, and you cannot have negative lengths because we're talking here about a right angle triangle with lengths of the opposite side and lengths of our adjacent side. So let's go to the calculator and type in tan inverse of 1 over root 3. So you can see here when I type it in, so that's typed in here. And then let's plus equal sign and we get pi over 6. So pi over 6. Now let's go to our rules up here on the right hand corner. We know that our complex number is in the second quadrant. So in the second quadrant, to find the value of our alpha, which is from here all the way over here, we're going to do pi minus our alpha, or pi minus our reference angle. So we have pi minus pi over 6, which is 5 pi over 6. So that's the value of our theta, 5 pi over 6. Now let's input both of our numbers into our polar form equation before we can move on to De Moivres. So we have 2 cos 5 pi over 6 plus I sine 5 pi over 6. That there is our polar form. Now, to go from polar form into De Moivres, well, you can see here that De Moivres has got z to the power of n. And in our question, our power is a 4. So we input our 4 into the 3 places specified by De Moivres theorem. So here it goes the power for the r, and then it goes in front of our alpha value, or our theta value. So let's do that. We have 2 to the power of 4 cos 4 5 pi over 6 plus I sine 4 5 pi over 6. Now, so next of all, what we're going to do is we're going to go to our calculator and we're going to work out what these are. So 2 to the power of 4 anyway is 16. And then we're going to go to our calculator and type in cos 20 pi over 6. So cos 20 pi over 6. So typed in here, like so. And we get minus a half. So we have minus a half there for this. And then we're not going to go and delete everything. We're just going to press the back button and delete that part now and put in sine instead. And we get out minus root 3 over 2. So minus root 3 over 2 I. Now let's multiply into 16. So 16 by negative a half is minus or negative 8. And then 16 by negative root 3 over 2 is negative 8 root 3 I. So there we have our answer. Z to the power 4 in De Moivres theorem is minus 8 root 3 I.